Hello class, this is a video tutorial on trigonometry, angles of any magnitude. In this video we'll be looking at angles that are greater than 360 and less than 0. So, having learnt of equivalent quadrant 1 ratios, the same concept can be applied to angles greater than 360 and angles less than 0. Now remember that the angle being measured in trigonometry always begins at the initial side. Here it is, the initial side, in case you can't see it. While the terminal side, this one here, this side can rotate about anywhere that we want for any angle that we'd like. Where it stops, we draw a triangle. That is the trigonometric triangle that we'll be using. So now I want you to take a close look and let's think about this. So starting from 0, we go anti-clockwise. We stop at 90. We can go to 180, 270, and all the way back to 360. And now if we want angles greater than 360, we simply go further again. What do you notice about angles that have gone past 360? So I'm going to leave this one here. This is angle of 330. That's an angle of 330. It would have gone around and then stop there. So let's say that is, sorry, not 330. Let's say that is 390 degrees. What difference do you see between that angle and, let's say, here's a new initial angle? What do you notice between 390 degrees and, well, that there is just 30 degrees? In reality, there is no difference because revolution angles, those that go around, will always have an equivalent ratio in the first quadrant. Likewise, if we go from 0, so let's start off at 0 and let's go backwards. Because we're going backwards, we are now in negative angles. So for example, here is negative 30 degrees. Let's get the purple. Going this way is negative 30 degrees. However, there's nothing different between that and having gone around this way instead. And as we've seen before, because we go clockwise or, anti-clockwise or clockwise, whatever this angle is, there will always be an equivalent angle in the positive quadrant 1. And this is the concept that we'll be using in order to understand and solve problems involving angles greater than 360 and less than 0. So let's get straight to it. Let's write the equivalent ratios of the following and let's evaluate it if an exact value exists. Sine of 390. Well, 390 degrees goes as follows. Here's 0 degrees. Go all the way around once, and then up 30 degrees more to 390. So 390 degrees loops around once, and then 30 degrees more. But that is the exact same as just going up 30 degrees. So we can say that sine 390 is the same as sine of 360 plus 30 degrees more, which really is the same as sine of 30 degrees. And if we can recall, sine of 30 is equal to half. Let's move right along. Cos of 540. Okay, so let's evaluate this. Here is my initial angle. Oh, sorry, initial, and here's my terminal. Going to go 90, 180, 270, 360, 90 more degrees. 360 plus 90 is 450. 450, and then from 450 add another 90 degrees. Is that 540? Now, this is actually showing the difficulty even I have until this point figuring out what the values are beyond 360. So what I tend to do is I just take the number that we have and we subtract 360 from it. Let's figure out what that angle is. 540, take away 360. That gives me cos of 180. So this is the same as cos of 180. And if we can recall, that is on the boundary. Cos of 180 is equal to -1. Moving right along. Tan of 945. Well, 945 is very hard to imagine. It's going around once, maybe twice, 3 times maybe. I'm not too sure, so we'll just use our calculator to figure out how many times it's gone around. So 945 degrees, take away 1 revolution, still not finished. 585, take away another revolution, it's 225. So this is the same as tan of 225. Now, if we can recall, 225 is actually down in this quadrant. And if we draw our right angle triangle here, this angle is, well, that is 225, and that is 180, meaning that this angle in between must be 45. So we can draw an equivalent quadrant 1 here of 45 degrees. Tan of 45, well, that is just 1, and tan in the third quadrant is positive. So tan of 945 is the same as 225, which is the same as +1. Sine of -90. Going back to our unit circle. Here's my initial at 0 degrees. Going backwards to -90. That's a 90-degree angle. We can see that the y value at this point is -1. So sine of -90 is the same as -1. Cos of -240. Let's think about this one. Here's -90, -180, and -240 will be somewhere here. So -240 is actually, let's think about this again. -240 is in the second quadrant. Let's figure out what this angle is here. Well, going this way is -180, and stopping here is -240. So -240 plus 180. That angle in between here is -60. So it's the same as if we were in this quadrant. So cos of -60 is this equivalent angle. So this is equal to cosine of -60. Okay, so cosine of -60, that's the same as if it were cosine of +60, which cosine of 60 is half. sine of negative 30. Let's draw this out so we can imagine it. So here's my initial angle. Here's 0 degrees, negative 30 degrees here. Well, that is the same as if we went around this way. Well, that angle will be 330 degrees. Well, that angle is the same as this triangle here of 30 degrees. However, because this angle stopped in the fourth quadrant, sine must be negative. So sine of negative 30 is the same as sine of 330, which is the same as negative sine of positive 30, which is equal to negative 1/2. Let's do two more. Tan of negative 115. Let's get rid of all these. So here we go. 0, negative 90, negative 180, negative 115 would be somewhere here. Let's draw that triangle. Negative 115 is there, so this is negative 115. But what the angle we really want is this angle in between. Well, that's going to be 180 degrees, take away 115. So 180 take away 115. That angle in between here is actually 65 degrees. But if we treat it as if it were coming from the positive side, right, that is the same as if it were here in the first quadrant of 65 degrees. So tan of 65 degrees, and because it's in the third quadrant, it's also positive. So tan of negative 115 is equal to tan of 65, which we don't have an equivalent ratio of. We could type it into the calculator if we wanted to. One last question here. Cosine of 690. Well, to understand this, we should figure out how many revolutions it's done. So 690 take away 360. So 330. Going back to our unit circle. 330 degrees. Here's 0. Goes around until we get to 330. 330. But once again, the angle that we are looking for, is this angle in between. That is 360 take away 330. And because we're looking for cosine, cosine in this fourth quadrant is positive. So this is the same as cosine of 330, which is the same as cos of, well, that's 360 take away 330, which is the same as cos of 30. Cos of 30 is root 3 on 2. So I hope that gave you an insight into angles of any magnitude, of negative angles, as well as angles that are larger than 360. Hope to see you in the next video. Best of luck.